Welcome everyone to the NXP EdgeVerse Techcast, where we talk about all things edge computing, cool tech, and the tools that make it all possible. I'm Bridgette Stone, joined by my partner in tech, Kyle Dando. Kyle, what's the big idea we're diving into today?
Well, thanks, Bridgette. Today we're diving into one of my favorite topics, and that's the Application Code Hub, or as we call it, the ACH. If you've ever browsed through it, it has over 150 applications. And you'll notice a common theme among those, and that's pretty much sensors. Lots and lots of sensors. So to help us unpack how sensors and MCUs work together to create a smarter, more efficient system, we've got the perfect guest. Amit, thanks for joining us today.
Thank you, Kyle, for having me.
Sure. So Amit Purohit is basically the godfather of NXP sensor software. Amit, before we get into all the cool work your team is doing, why don't you introduce yourself a bit?
Sure. Hi, my name is Amit Purohit, and I'm associated with MEMS sensor product line at NXP based in Chandler, Arizona. I've been part of Freescale and now NXP for more than 15 plus years. In my previous roles, I worked on digital signal processors and later on to PowerPC based heterogeneous architectures for wireless protocols development. As part of my current role, I'm driving the sensors development ecosystem and tools strategy for NXP sensors business. My focus has been to help improve the ease of use for our customers by providing a good out-of-box experience during their evaluation phase and creating differentiated solutions with NXP sensors.
Thanks for the introduction, Amit. We're so happy to have you. Now, integrating sensors into the MCUXpresso ecosystem has been a long journey, and you've been at the forefront of this effort for years. Tell us how it all started and what kind of impact this has had on the sensor enablement at NXP.
Yeah, sure, Bridgette. So my journey has been a path of continuous learning, and it is filled with the satisfaction of helping our customers by improving their development experience with a unified set of tools provided by MCUXpresso ecosystem. Also, I feel that integrating sensors into MCUXpresso ecosystem helped optimize sensors enablement delivery with quality. I started sensors integration into previously known KinetisXpert SDK in late 2016 and have been involved since then to support sensors integration to the latest MCUXpresso SDK that we have today. It's been over 8+ years of great collaboration with the SDK team. And now when I look back, I see how the SDK has matured from the KinetisXpert to the MCUXpresso SDK. It has been built into one of the finest development ecosystems in the industry.
That sounds like a massive evolution. And with every big shift like this, there are always challenges. But I imagine this has also been really rewarding for you personally. What's been the biggest benefit for both you and the NXP sensor product line?
Yeah, that's a great question, Bridgette. Integrating sensors as a middleware component into MCUXpresso SDK has been challenging. Let me tell you, by the way, the sensor software was the first middleware successfully integrated into the SDK and became a reference at that point. I strongly believe that it has added a lot of value and transformed the way NXP enables customers to design with our sensors. Of course, these efforts have also benefited me. I had a great learning experience working with the SDK team across the globe. I have made very good friends while establishing mutual respect for the jobs that we do. But in my opinion, the most important aspect has been that this integration has provided excellent opportunities to show more of the complete solution that NXP can offer. The sensor product line over the time started understanding the importance of attaching sensors with MCU development ecosystem. And this effort helped make it easier for customers to successfully pair these two products to jumpstart their development. According to me, this has been a good example of the brighter together mindset promoted by NXP.
That's true. It is. I think it's a great example of our brand of being brighter together, Amit. Now, Amit, you mentioned that the sensor's middleware component is a key part of the enablement. And I like to think that the middleware is that trusted bridge between the microcontroller that you mentioned and the sensors that they may want to use from NXP. So explain a little bit more about what it is in that sensor middleware, but also show how you have made it a little bit more valuable for the developers.
Yeah, thanks, Kyle. I was hoping that you would pose this question to me. So as you are aware, middleware in an SDK, it acts as a glue layer, connecting the SDK features to the external system for extending certain applications. We created ICE SDK, we call it IoT Sensing SDK, and it's being offered as a middleware component in the MCUXpresso SDK ecosystem. ICE SDK combines a set of robust sensor drivers and algorithms along with example applications to allow users to get started with NXP sensors. What we changed there is we changed the sensor driver design to come up with the CMSIS compatible low-level drivers. And then we also created easy to read functional APIs to improve the code readability for our customers. This way, we were able to demonstrate a modular and separable layer cake architecture. In summary, implementing CMSIS compliant sensor drivers to connect to peripheral drivers provided by SDK was one of the key features that has helped us a lot for easy porting across the NXP MC portfolio. Apart from that, the way we have exposed sensor register bitmaps for easy access to configure sensors is another useful design feature. And last but not the least is the concept of board shield GPIO mappings that we have added. This actually helped us to provide a seamless migration to support multiple MCUs without changing the sensor drivers.
So Amit, you and I worked quite a bit on the CMSIS drivers, and I know that the feedback from our engineers and customers is that they really like how those CMSIS drivers allow the projects to be a little bit more portable because that common CMSIS driver can be used across multiple boards. So that was huge. I'd like you to drive a little bit more into how you simplified things for the developers. The sensor team has done a great job of embracing the Arduino connector and the form factor, and that has made it really easier for the customer to take that one sensor or that one board and move between different products. So beyond that hardware, how did you using the Arduino connector and the Arduino form factor improve the software enablement with sensors?
Yeah, and that's a great point, Kyle. Thanks for reminding me of that. We decided to adopt the Arduino form factor for the sensor evaluation boards to better align with NXP's evaluation kits or freedom development boards approach. What I really liked about the MCU board design is the way it extends flexibility to connect add-on expansion boards and provides the freedom to innovate for our customers. This approach has certainly helped simplify sensors enablement. As I mentioned in my early comment, the board shield mapping concept that we added was built since we were able to utilize the Arduino form factor, which is a standard expansion pin mappings. And this allowed us to use sensor shield boards like Lego blocks. And what I mean by that is we are providing this flexibility to developer that they can swap between boards with very minor changes in the respective board shield and GPIO mappings, and they can run the same examples with no other change required. With such stackable expansion board options, we are offering freedom to innovate.
Thanks, Amit. I know we were talking a little bit about the power of middleware, and I think one of the best ways to talk about this is through real-world applications. With all the work that you've done, you must have a favorite ACH example that really highlights the value of sensor integration. What stands out to you?
Yeah, so when we started having the sensor middleware integration and CMSIS driver compliance, it actually helped us to move quickly in bringing up application-specific examples. With the flexibility to port faster on multiple Cortex-M based microcontrollers and combining multiple middlewares available for those MCUs, we are able to demonstrate cool application examples through ACH. My favorite sensor-based ACH examples are, of course, the one showing the ultra-low power wake-up features of sensors to help optimize overall power consumption of the system. Now, you might be wondering, out of so many sensor-based cool applications available on ACH, why I'm choosing the low-power examples. I always get this question, why do we need to care about low-power designs? Let's look at some interesting numbers and see whether that answers our question. So based on some estimations by EDNA, which is an initiative of the International Energy Agency, by 2030, there will be more than 75 billion connected edge devices. More than one third, that is more than 25 billion, will be battery-powered IoT devices that will be deployed in remote locations. The associated energy use and waste from batteries will be considerably huge. There's another study done by Enables, which is an EU-funded research infrastructure project. According to them, up to 78 million batteries will be discarded daily around the globe in next few years if we do not improve the lifespan of batteries or reduce the energy consumption powering these IoT devices. This will cause major environmental and economic problems. Currently, we are at the 40% of the capacity to recycle these batteries. So this tells you why integrating low power features are very critical for IoT applications and also for optimizing system battery power for a sustainable future.
That's truly a compelling use case, and thank you for sharing that information. It really ties well into a growing challenge, power efficiency. With billions of IoT devices expected to be battery powered, reducing energy consumption is absolutely critical. So what key sensor features are helping to drive these kind of trends for low power optimizations?
Yeah, that's another very good question, Bridgette. So many of the key features of the sensors are demonstrated in the ACH examples, but I can mention just a few of the most important ones here. Most of our low power sensors feature flexible and configurable digital comparator embedded function. We call it SDCD, that is sensor data change detection function. For example, SDCD functional block for motion sensors implements an inertial event detection function with the ability to detect motion events like motion to no motion detection, tap, free fall shocks, and other transient acceleration events. Such embedded functions allow users with the flexibility to configure sensor for required motion gesture-based wake-up. They don't need to write complex algorithms to do the post-processing on the raw data. This is all done by this embedded function block within the sensor. Another key feature that we have demonstrated through these ACH examples is our auto wake sleep feature. This feature allows developers to make the system totally autonomous. What I mean by that is user can configure their wake-up based configurations using the SDCD block. And by configuring auto wake sleep, the sensor can work autonomously. It can go back to sleep mode when the configured wake-up event has not occurred for continuous configured amount of time. Let's say an example, 10 seconds. If there's no motion wake up happening for continuous 10 seconds, sensor is capable of going back autonomously. Then it can wake up again based on the wake up condition met. Finally, the developer can find examples where sensor is configured to work in the interrupt mode. That's a very important feature because then all of these SDCD and auto wake sleep can be tied in with an interrupt feature. Sensor can raise an interrupt to wake up the host MCU and system, or alternatively, raise the interrupt to put the host MCU and system to deep sleep mode using auto wake sleep feature. Combining all these three features, we showcase how our low power wake up sensors can play a critical role in extending battery life for the overall system solution. Also, I would like to take advantage and mention that devices are getting more and more complex with more competitive content in them. The low power design aspect shouldn't be an afterthought, in my opinion. Rather, it should be the first thought when designing such connected edge devices. The low power wake up sensor ACH examples describes how a developer can use these key sensor features in their next design to enable effective power management for low power operations.
So I've worked with most of the sensor projects in the application code hub, and I agree that the low power wake up feature of these sensors is really powerful. And you do a great job of showing customers how they can get started and how to truly take advantage of those features in the sensors. I did notice though that you also include FreeMASTER in most of those sensor projects, and this tool FreeMASTER may be new to our listeners. We haven't had an episode covering that. So can you introduce what FreeMASTER is to the listeners and maybe how you have included it as a very unique tool that has helped accelerate sensor development for the users?
Sure, Kyle. Yeah, and I agree. That's a good observation. So as part of my current role, I'm always trying to find ways to improve ease of use for our customers by providing good out-of-box experience. During my involvement in integrating sensors into MCUXpresso SDK, I learned about another middleware component, and that is FreeMASTER. This tool was promoted as a runtime debugging tool. That means this tool was initially created to have some kind of debug counters, some kind of watch variables. And when you provide a debug release, debug version of your binary to customer, they can actually do the field debugging in real time. When I started to learn more about it, I thought I could use this tool to create an evaluation GUI tool for sensors. Some of the cool features of FreeMASTER tool, like ease of adding watch variables into the memory mapped target site addressable TSA area, their proprietary communication interface with the host, and the ease of importing the TSA mapped watch variables on the host GUI helped me to transform this tool into a sensor evaluation tool. We have successfully adopted this tool as sensor evaluation tool. We integrated sensors middleware with FreeMASTER middleware on the target side for supported MCUs. Also on the host side, we have been able to create sensors control page that gives easy access to users to evaluate our sensor specs like full scale range, ODR, sensitivity, offset noise measurements, running self-test diagnostics, and configurable power modes. We also extended the GUI features to include a very extensive register page for sensors, where user in real time can read all sensor registers, modify bit fields of sensor registers, and see the behavior in real time. This is helping customers to not go through the data sheet. They can use this tool and evaluate the part very easily. Also, this tool provides sensor data visualization, data logging, and many other features.
Thanks, Amit. We're coming up here to our last question. I want to talk a little bit about what's next and in the future. And we know that Application Code Hub and Expansion Board Hub have already made it easier for developers to explore and implement new applications. So looking ahead, where do you see these tools evolving?
Well, I've been seeing the pace at which MCU enablement is transforming to meet customer needs. The Application Code Hub and Expansion Code Hub are great examples confirming how NXP is extending its development ecosystem to allow better engagements with our customers. While the MCUXpresso SDK tools and evaluation boards built a strong, good foundation for our customers, there always have been a strong desire from open source developers community to have a quick and easy way to search for application specific examples supporting specific targeted families with various expansion boards. ACH provides a list of application-specific examples developed by NXP in-house experts and provides an easy way to search available example by device family, application type, and other categories. And Expansion Board Hub provides a database of NXPs and third-party expansion boards to expand NXP's MCU EVK capabilities. Expansion Board Hub also helps links associated enablement software for bringing up those chosen target platforms and expansion boards. Looking ahead, I would really like to see our FAEs, sales team, and our customers to make use of these tools. And I believe we can achieve this by educating them and spreading more awareness on how to use these tools. And at this point, I would like to share a success story that I totally loved when I heard it firsthand from one of our FAE. This story confirms how these tools are helping our NXP teams to cross-promote, cross-sell, and gain customers' confidence. So recently, an FAE visited a customer site that is in the healthcare space to discuss NXP's wireless connectivity offering based on customer's request. But when he learned more about the use case, it took him no time to bring up a sensor expansion board and an available ACH example to quickly demonstrate to the customer how the sensor feature adds value to the customer use case. This quick and live action helped gain customer confidence, and customer immediately showed interest in evaluating the sensor part. I'm sure there are more such examples available where our tools and integration of multiple technologies to reduce complexities is making a huge difference and helping our customers. With this approach, we are driving a true value proposition for our customers.
That's a great story. As a former FAE, I spent 10 years in the Bay Area visiting customers. There's nothing more powerful for a customer or for an FAE than to be able to plug a board in, go to an example that somebody else put together, and show quickly that what we're talking about actually works. Because as salespeople and as customers, sometimes we're skeptical that all we're doing is hearing a good story. But I think the application code hub and all your sensor examples is the evidence that the customers really enjoy. And NXP has done a great job of positioning your products along with the MCUs to make sure those customers have that confidence. When we explain to them that we have a solution, they can get it and they can use it. So thanks again, Amit, for joining us today. It's just been a pleasure to have you on the show. We explored how NXP is working to make sure that sensors and MCUs are brighter together. From seamless middleware integration with projects in MCUXpresso to providing a powerful visualization tool in FreeMASTER, we've learned that the application code hub is helping developers discover the different use cases for the NXP sensors. And these sensor application examples are helping them bring their projects to life faster and more efficiently.
Thanks again for your time today, Amit. And if the listeners enjoyed this episode, please be sure to like, subscribe, and turn on notifications so you never miss an update. And if there's a topic you'd love for us to cover, let us know. We would really like to hear from you.
So that's it for today. Keep innovating, everyone, and we'll catch you on the next EdgeVerse Techcast.